Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azizi bin Zulkifli and my supervisor is Associate Professor T.S. Dr. Nur Haslina binti Hashim. So my title is Wind Rose Analysis for UTHM and Possible Pollution Source Zone. So we go through the abstract first. So the nearby urban areas such as industrial park or city can distribute a factor of increasing distance from the pollution concentration. The concentration of pollution that dispersed in the atmosphere then can be affected by several factors such as wind speed, wind direction, air pollution concentration, temperature, and the precipitation. Pollution that caused by non-point sources and unknown source can make the source identification become more difficult. Therefore, in this study, the wind speed and the wind direction at 3 different sites at the UTHM Parit Raja campus were analyzed in order to predict the possible pollution source zone. Due to the Movement Control Order (MCO) during COVID-19 pandemic, the analysis was only conducted to the previous collected PM2.5 data from March 2020 until 21 July 2020 in the 3 different locations at UTHM Parit Raja campus. So the next is introductions. Air pollution and air movement are very significant in the increasing of air pollution in that area, which is nearly with air pollution emission areas such as city, industrial area, mining area, and another related area. Given that influence of weather pattern or local air quality usually varies over the time, air pollution can occur due to distribution of wind into the nearby area such as residential area, college area, and another related. The aim of this study is to predict the air pollution movement in the UTHM Parit Raja campus by using wind rose diagram, and the main objective of this project have three. First is to determine the air pollution index (API) based on the maximum PM2.5 concentration in March 2020, April 2020, June 2020, and July 2020. The second is to establish wind rose and pollution rose at UTHM Parit Raja campus in March, April, June, and July 2020 by using WUpload View software. Third is to identify the possible pollution source zone based on the projection of 1 kilometer distance from the sampling point at the 3 selected location at the UTHM Parit Raja campus. In the literature review, the air pollution is the largest environmental risk compared to another are related. That is more than what the WHO estimates 6 million parameter deaths by exposure to air pollution in 2012. There are several factors of air pollution, such as air pollution. So in air pollution, we are determine the source of air pollution and effect of air pollution. So for source of air pollution, there have industrial area, main road, mining area, and so on. So for effect of air pollution, they have lung cancer, difficult to breathe, and other. Next is factor affecting the air dispersion. For this project, we are determined to wind speed, wind direction, and air concentration. So the wind speed have a velocity of the wind, and then next is wind direction, which is the direction movement of the wind, and then the air concentration, which have a particulate matter, ozone, and and then carbon dioxide, and so on. So next is air pollution monitoring. For this project, we use the e-sampler, which is to collect the data. And next is software, which is we use a wupload view to analyze the data. And the last is windrows diagram to predict the air pollution movement in the area, which is 3 selected area. And the last is ambient air quality standard, which is we use the NAAQS and the API in Malaysia. Next is methodology. For this project, we are started in start, and then we are selected area which have a three area in Uthm Parit Raja, such as Tun Dr. Ismail Hostel, Rugby Fields, and Post Guard. So next is collection PM2.5 concentration data. Basically, for this collection, we have taken previous data due to in MCO. So next is analysis of PM2.5 concentration. And next is generating by using wupload view software. For this software, we can generate the windrows diagram and the pollution rows diagram. So after we got two of this diagram, we analyze and discuss of the wind distribution. And the last is we ends. So for the result and discussion, we have a three diagram, which is the first is average of concentration, second is windrows diagram, and third is the air pollution rows diagram. So we go through the first is the average of concentration. For this graph, we are separated to the month, which is first is March, April, June, and July. So in the March 2020, which is in the Tun Dr. Ismail Hostel, the highest of average the concentration PM2.5 is 51.67 microgram per meter cube, which is in API's value is 18.63 with the moderate value. Next is in April 2020 in the rugby field. In this diagram, we can see the highest value of concentration is 32 microgram per cube, which is the API value is 66.4, and this value is in moderate value, which will not be harmful to humans' life. So next in the third diagram is June 2020, which is in the Post Guard. For the Post Guard, we can see the highest value of average concentration in 30 June 2020, which is the value is 21.71 microgram per meter cube, and the highest and the API value is 58.44, which is in the moderate value. And the last diagram in the average of concentration in the July 2020. In this figure, we can see the highest of average concentration PM2.5 is 13 July, which is 113.71 microgram per meter cube, and the value of API is 151.151, which is we can determine that it's not health for the sensitive group. So they have so next is a windrows diagram. So for the first figure, we can see the distribution of range of the wind direction, which is 1 kilometer from the TDI, which is Tun Dr. Ismail Hostel. From that range, the industrial and main road is including in the area, which is that can influence to increasing of air pollution in the campus area and or in the residential area. So the second figure is shown in the rugby field. So in the rugby field, the range is 0.4 kilometer, which is the range is more smaller than the first figure. And then in the range, if including the main road only. So the third diagram is in the postguard in the June 2020, which is the diagram shown the pollution distribute to the TDI and the campus area. For this diagram, we did not find out the point source, but this figure can show that the air pollution distribution to the campus or to residential area. The last figure in the windrows diagram show that the wind direction is in the many direction, which is in campus area, residential area, and so on. So next is the pollution rows diagram. For the first diagram shown that in the TDI, which is March 2020, the diagram showed that the highest concentration of PM 2.5 distribute from the TDI to the industrial park. For this month can affected the residential area in increasing the highest of air pollution, and also in campus area have a little wind direction to the campus area, which is can influence to increasing the air pollution increasing. So second figure in fields, in rugby fields, which is you can see the wind direction mostly to the residential area, which is can affect to increasing of air pollution at the residential area. So the third figure shown in the postguard, which is in June 2020. For this figure, we can see the pollution are distributed to campus area, which is can be increasing the air pollution in campus area. And third, in fourth figure shown that distribute to all direction, which is the highest of concentration PM 2.5 distribute to the campus area and the residential area. So for the conclusion, that the result show that the maximum concentration of PM 2.5 is 113.71 microgram per meter cube on the 13 July 2020 at the postguard. The prediction of the air movement for this project has been established windrows diagram and pollution diagram in UTM Parit Raja campus on the March 2020, April 2020, June 2020, and July 2020. From the analysis of windrows diagram, the project has been determined that the possible source were 1 kilometer distant from the sampling location at UTM Parit Raja campus. So that's all for me. So thank you. Bye bye.